Okay, so x-intercepts, roots, zeros, these are all 3 different words for the same thing. Here are each of those, just to recap for the video. Next one, y-intercept. I think we know this one as well. The y-intercept is where we're going to cross the y-axis, so I'm going to mark this one in blue. If you don't have different colors, just put little labels on your graph as you go. Okay, so the next column here, we have the words positive and negative, and then we have increasing and decreasing. Okay, so positive is different than increasing, and negative is different than decreasing. The positive sections of the graph and the negative sections of the graph are where y is positive and where y is negative. So this right here is a positive section of the graph. Here's another positive section of my graph here. The negative sections are the ones below the x-axis where the y's are negative. So I have, let's get a highlighter here. I've got negative here and negative here. Okay, so above the x-axis, below the x-axis. Okay, increasing and decreasing. The general rule is as I move my pencil from the left of the graph to the right of the graph, if my pencil is going down, I am decreasing. If my pencil is going up, I'm increasing. Okay, as I move left to right, same way that you would read. So a negative section, or sorry, a decreasing section, as I move left to right here, my pencil's going down, 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 down until I hit here. That is a decreasing section. Another decreasing section sort of starts here, and my pencil will go down, 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 down as I move left to right. So those are 2 decreasing sections. The increasing sections. Am I going too fast, guys, for you to change colors and stuff? Yes? Okay. I'll give you guys a second to get caught up here then. Okay, increasing section is, of course, anywhere that you're not decreasing for this graph. And that's this section right here. Okay, as I move left to right, my pencil goes up. So that's an increasing section. Okay, and if you need to, you can also just sort of label along here for both of these pieces. Decreasing, increasing. We talked about this a little bit yesterday when we talked about turning points, our graph changing from increasing to decreasing or decreasing to increasing. And that brings us to our turning points. So our turning points fall anywhere that we have that change from decreasing to increasing or increasing to decreasing. So what color can I use for this? Let's see. What haven't I used yet? I used green, orange. Okay, so here's a turning point right here, top of a mountain. You can label that one now that we've got a lot on here. Here's another one down here. Changes from decreasing to increasing. Okay, and then sort of like along with the turning point here, turning points can be called local maximums or local minimums, depending on whether they fall at the bottom of a valley or the top of a mountain. Which one of these turning points, the left one or the right one, do you think would be the local maximum here? What would make sense? Kenzie? So it's like sort of at the peak of a mountain, right? That's going to be a local max. And then, of course, if I see something at the bottom of a valley, That's sort of like a local minimum area. It's a local low area, right? So this one is going to be a local min. So these three kind of go like hand in hand, turning points, and then we can further label those turning points as a local max or a local min. Okay, and then our last one is end behavior. We learned about this guy yesterday. It's basically just where the ends are and what they're doing. So we would just say, like, right along the ends here, we have some sort of end behavior that's happening. Okay, so who can tell me what is the difference between positive and increasing? Positive and increasing. Michael, is that a hand? Okay.
Like positive is like when it's like above the x-axis, and increasing is just going up. Like it can be below the x-axis and still be increasing.
Perfect. Did everyone hear that? Okay. So then, on the other hand, what's the difference between negative and decreasing then? Keaton?
Negatives below the x-axis, and decreasing is going down.
Yeah. Going down as we travel left to right, right? Because if I were to travel right to left, that would reverse. So we always want to be traveling left to right to decide whether our pencil's going up or our pencil's going down. Okay, great. Any questions on this so far? Okay. Let's continue. All right, so I'm actually going to flip sort of between this and some of our homework questions, because our homework questions will give us some visual graphs of what's happening here. So we're going to fill in some sample sketches of graphs that would follow having certain even degrees and certain positive or negative leading coefficients. And then we're going to talk about the end behavior. And there's 4 combinations that we can have. I can have an even degree polynomial with either a positive or negative leading coefficient, or I can have an odd degree polynomial with same thing, positive or negative leading coefficient. So I want to look at an example where we have this, an even degree polynomial with a positive leading coefficient. Can someone give me a number from the homework that fits this description? Even degree, positive leading coefficient from your homework. Kenzie, did you find one? Or just give me the number. Number 2 fits this description. It is degree 2, and it has a leading coefficient that is positive. Okay, so something like an x squared. Are there any others in our homework that have an even and positive leading coefficient? Sir, what?
Question 6.
6 is even. It's degree 4, and it has a positive 1 as the leading coefficient. Okay, so we should notice, actually, in both of these, 6 and 2, the end behavior is actually the same, right? So it goes from quadrant 2 to quadrant 1. Both of them do, both 6 and 2, 2 to 1. And then they both have y's that approach positive infinity for the left end and the right end. So their ends are both facing up. This is going to happen for any even degree polynomial that has a positive leading coefficient. That will happen all the time. So if I just have an equation and I know that my degree is 6 and I know my leading coefficient is positive, I will know the end behavior right away because it will always follow this, this idea. Okay, so here's a sample sketch for you. Any even and positive polynomial is going to sort of follow this pattern. It might be shifted up, it might be shifted down, it might be shifted left or right, but if we extend the ends, it will always sort of go into these quadrants eventually. So as we saw from our homework, any even and positive polynomial for degree and leading coefficient is going to go from quadrant 2 to quadrant, we'll just say Q2 to Q1. Okay, and that's because we have quadrants 1, that's not going to work. That's because we have quadrants 1, 2, 3, 4. Do this, I'll just do it lately. 1, 2, 3, and 4. So we can see that our ends here are going from 2 to 1. Okay? For our statement of end behavior, this is a good little review for us from last time, just to remind ourselves. We always have this, no matter what. We will have, as x approaches negative infinity, because we want to say what the left end does, and we will always have, as x approaches positive infinity, so that we can say what the right end does. So as x approaches negative infinity, so the left end, what does the left end do? Does it go up or down? You right? It's going up, right? It's facing this way. So we're going to say y approaches what? Kenzie? Positive infinity. Okay, so left end is facing up. This is literally the only part that I should have to enter in for this part, and then the next one for the right end, right? Everything else is the same always. Okay, and then this one is as x approaches infinity, so the right end. What are we doing, up or down? And what does that mean? Nick? So what do I fill in here? Positive or negative infinity? Positive infinity, perfect. Okay, and that was the end behavior of both question 2 and 6 on our homework. Okay, it will always be the same. Okay, let's find an example on the homework that had an even degree but a negative leading coefficient. We'll see what that does. Lois? Number 3, let's look. So even and negative, yes. So by the time we expanded that out, okay, so this one you had to expand to properly see everything. The degree was 2, and the leading coefficient was -0.5. Were there any others that had even and negative, or was that the only one? That's the only one? Okay. So any even degree polynomial that has a negative leading coefficient, whether it's 2, 4, 6, 8, if it has an even degree and a negative leading coefficient, it will follow sort of this general pattern. So here's what it's going to look like. Oops. It will essentially be kind of like what we have above, but flipped downward. So if we think about transformations from last year, it's sort of like just the same as what we have above. Could be shifted any way, like could be shifted left, right, up, down, could be stretched or whatever, but it's always going to follow this general pattern. So if these are our quadrants, what would we say for quadrant notation for this one? Michael? Yep, so from quadrant 3 to quadrant 4, always, for all even and negative leading coefficients. Okay, so for end behavior, I'm just always going to write these. Whenever I do end behavior, just start with this, because you're always going to have that piece. So left end, as x approaches negative infinity, is our graph going up or down? Down. So what should I plug in for this first piece? Negative infinity. Perfect. Okay. Right end, as x approaches infinity. So as we go this way, up or down? Zach, down. So Zach, what would you put in here? Negative infinity. Perfect. Sweet. And if we look back at our question number 3 from our worksheet, we'll see that we probably filled in the exact same end behavior for that one. Okay, odd and positive. Give me an example from the homework that has an odd degree with a positive leading coefficient. Keaton? What number? 5. 5, once we expand it, yep, has an odd degree and a positive leading coefficient. Perfect. So this is a good picture of what we could expect something like that to look like. S-shaped, and it's going to go sort of like up to the right, almost like it has like a positive slope. If we were to put a line through it, right, that has a positive slope or positive direction. So that's what we'll get. So odd and positive in general. And lines will sort of follow this same like quadrant behavior too. So it's going to be just something like this, right? It will be S-shaped, heading in that upward direction. Or we could even have like a line that's sort of heading in that direction as well. Same idea. Okay, so what would quadrant notation be for this type of polynomial then, Matt? Yep, 3 to 1. And then when I'm doing end behavior in infinity notation, we're just going to write this down right away. Left end, right end. And then we'll fill this in. Okay, so again, I want you guys to notice I have literally the same thing for all of these every time. Okay, can someone fill these in for us? Ian?
The first one, infinity, and then the second one is positive infinity.
Okay. Do you guys agree? Okay. Anyone disagree? Okay, he's right. So left end is facing down. So I want to say for the left end, which is as x goes toward negative infinity, my end is going down. And for the right end, our end is going up like this. So we want to say positive infinity for that. Perfect. And again, if we look back at that example that we took from our homework, that would be the same end behavior that we had put in for that. Okay, our last one. Do we have anything on our homework that is odd and has a negative leading coefficient? We might have 2 examples for that one, maybe. Andreas?
I think 1.
1? Are there any others? I don't know. Okay, so 1 is really the example here. So odd and negative. So it could be a line, almost like the line has a negative, well, the line does have a negative slope, or it could be S-shaped, right? But in general, the end behavior will be the same, whether it's a line or whether it's S-shaped. So essentially, we'll have something that kind of cuts through like this. Again, it might be more S-shaped. It could be more straight, like a straight line, but it will always kind of follow that direction down, almost like we're traveling down a mountain. Okay, so who can do quadrant behavior for us for this one? Yuri? From quad 2 to quad 4. And then we're going to just fill in as x approaches negative infinity. We'll choose what y does. As x approaches infinity, y approaches. Michael? Very good. Okay, so we are saying the left end goes up. That's what we're saying with this statement. As x goes toward the left, y goes up. And then this statement is saying as we go toward the right end goes down. Good. Questions on this so far? Okay, so if I threw out an equation to you, we should now be able to predict. We don't know exactly what the shape is going to be, but we should be able to predict like what the ends are going to do. Are they both going to be facing up? Are they both going to be facing down? Will they be opposite? Will they be this way? That's what we should be able to do. Okay, so I want us to notice a couple patterns here as well in this table. The sign of the blank end behavior is the same as the sign of the leading coefficient. So it might help us to look at our homework questions. What do you notice about the sign of the leading coefficient and the other things that we filled in the chart here? What is the same in every single one of these as we look down? Sarwa?
The sign of the right end behavior is the same as that of the leading coefficient.
Okay, so if I know the leading coefficient's positive, I actually know that the right end will be doing this. If I know that the leading coefficient's negative, I know the right end will be doing this, okay? You can see that in all of these charts, the sign of the leading coefficient matches the sign of the right end behavior, up or down, okay? So that gives us some indication too. That's a helpful little thing to know. So the sign of the right end behavior is the same as the sign of the leading coefficient. Okay, polynomials of even degree have blank end behavior. What do we notice about these two even degree polynomials and their end behavior? Zach? They're the same. So either it's both positive infinity, they're both facing up, or they're both facing down. And that's for even degree polynomials. So we will say the same. Okay, so we might be able to guess or observe what's happening with odd polynomials. What's happening with both sets of these odd degree polynomials here with the ends? They're opposite. Okay. So always with odd, one is going up, one is going down. Always with even, they're both facing up or they're both facing down. My thing just stopped working here. Let's do this. Okay, so I'm going to give you, I just want to give you quickly a sample equation. And of course, my program just stopped working here. Okay, this is just a little self-check to see if you can sort of read that chart and understand everything that we just did here. Slowly yet surely, it's going to happen. Okay, so, and it's still not working. Okay, now it's working. Okay, so example, we have a polynomial. We're going to call it p at x. And let's just throw out some okay. We should be able to, without even graphing this, know what the ends are going to do. So if I were to just sort of predict on the graph where my ends are going to be, like this, 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 or this, we can do that by looking at the degree and the leading coefficient. So firstly, what is the degree here? Rebecca? Degree is 9, correct? That's the x with the highest exponent. What is the leading coefficient? Andreas? 5. So in other words, the leading coefficient is positive and the degree is odd. So automatically, if I know the leading coefficient is positive, Amelia, question? Pardon? Oh, sorry, that's a 7, not a 9. So you can only add if they're the same exponent. But yes, sorry, I think that was just my rating. It looked a bit like a 9. But yes, if it was a 9, we would add together. Okay, leading coefficient is positive. What do I know about the right end now? Nick? Okay, so I know the right end's facing up. The degree is odd. So what do I know? We just said odd degrees have opposite end behavior. So if my right end is facing up, what do I know now about the left end? Rebecca? It must be going like this, right? So this is my general shape. I know it's going to be sort of like S-shaped and going like this. Okay, so we have something where the end is here. I'm not going to sketch the whole thing. And then we have another end ending here. Maybe it goes like this. I don't know. I don't even know what this looks like, to be honest with you guys. I don't know exactly what it looks like. It could be different, right? Like, could be anything, really. But I do know that it goes from quadrant 3 up to quadrant 1. for sure. Okay, so automatically, that's what I know. Okay, so that's kind of how we can use this quickly to decide what the ends are doing. We're going to fill in some gaps a little bit later in like this unit and next unit, how we can actually see what the inside of that will look like. Keaton?
Could we do the infinity end behavior?
Yes, so we can do infinity end behavior. I know because we're odd and positive, or sorry, yeah, odd and positive, this is going to be our infinity end behavior, always. Okay? So that's the idea. Okay, so we are going to have some time here to do some work. My goal is that we'll also do lesson 3 after we get back from our break today. So you guys have a half hour right now.